Again, Year 11, and welcome to the Night Before News in preparation for Paper 3 of your Maths PPEs. We know the drill by now in terms of the advice that I'm going to give you, making sure that we read the questions carefully, making sure that we answer every question, and using your time effectively in the exam, trying to work at approximately a mark a minute so you've got that time at the end. I'm just going to get us on to the list of topics that I think are likely to come up. I did this in Paper 2, and I explained that it's quite difficult to predict what will come up in Paper 2 because you've still got those 2 papers left and they're both calculator exams. So all of the topics that we haven't seen in Paper 1 could come up, but there's no guarantees. At this stage, having seen Paper 1 and Paper 2, it does say Paper 1 up there in the corner, but it really should say Paper 3. We have a better idea of what's going to be coming up in this exam, because some of these things have come up, but still not very much, or they haven't come up at all and are very likely to. Some of them haven't come up at all and might not, but they're well worth revising. And just because something has come up previously, that doesn't mean it won't come up again. It does mean that for some topics, but not for very many. But I've picked out some things here that I think are particularly important to revise because I think they're particularly likely to come up. Again, I can't make any guarantees for you, unfortunately, but do please have a look at some of these things. And because there's quite a lot here, I'm going to do this video slightly differently. I'm not going to go through an example and then give you one to try. If you want to try the questions in advance, then just pause the video when I get to the examples and give them a go. But then I'm just going to go through one. I want you to watch this, and then I want you to kind of get stuck into the rest of this list. So just to talk through it quickly, we've got percentages. You have seen more percentages now in Paper 2, but I'm still absolutely certain you will get more come up in Paper 3. That could even include compound interest. You had a simple interest question in Paper 1, but there's no reason why compound interest couldn't still come up. Pythagoras will come up in this paper. I'm going to guarantee that now. Similar shapes is a fairly common topic that we haven't seen yet, so I want you to be prepared for that. You have had some averages. You have actually had a frequency table, but it is something that can come up more than once. You could get a group frequency question where you're asked to estimate the mean. There are more statistical graphs that we could end up seeing. In particular, scatter graphs, frequency polygons, pie charts. Make sure you've got a protractor ready for that pie charts question if it comes up. Also bar charts, which I haven't listed on here, but we haven't seen any of those yet, and again, they're quite common. Area, still haven't seen any circles, still haven't seen any trapeziums, and they're both very, very common, so expect to see at least one of those two, but very possibly both. You will absolutely get more algebra skills coming up in this exam. I've listed here substitution and factorizing quadratics as 2 skills that I'm particularly expecting to see. On factorizing quadratics, just because I looked it up earlier, the clips on Hegarty that you want to be looking at are 223 and 230. The first looks at just factorizing quadratics, and the second looks at solving quadratics, either of which could come up. The clips in between are really focused on higher GCSE content, so just look at those 2. You have had compound measures in Paper 1, but I'd be surprised if you didn't get a question in a calculator exam as well. So speed, distance, time, density, mass, volume, force, pressure, area, any of those could come up, possibly even a couple. Probability I mentioned last time, and again, we've seen a little bit more, but particularly thinking about things like two-way tables, which we still haven't seen, probability trees, which we haven't seen. I think you will get more probability questions. Simultaneous equations, I said before, did technically come up in Paper 1, so you may not get it here in Paper 3, but at the same time, I wouldn't be at all surprised if you got a more conventional question where you're just given 2 equations. I've got an example of a simultaneous equations question coming up for you. Angles in polygons. You had angles in a quadrilateral in Paper 2, but I'd be surprised if you didn't get a slightly more complex question than that, so something with a pentagon or a hexagon, for example, possibly a regular shape. Bearings is another big one that we've not seen. That could be scale drawings, so it could be to do with you measuring angles. So again, make sure you have a protractor, or it might be to do with you actually working out missing angles. And it could be relating to you measuring distances and then scaling them up or down as well. So make sure you've got a ruler ready that you can actually measure with, not just use to draw straight lines. Properties of shapes is quite broad. So 2D shapes and 3D shapes. And that might be naming different shapes. Parts of circles is something that could come up in there as well. So things like chords and tangents. And on 3D shapes, you could be asked questions about numbers of faces, edges, and vertices. And finally, something quite specific. I do think you'll see more ratio, but in particular, ratio with 1 to n, which is a really easy thing to revise. If you type 1 to n like this in on Hegarty, then a clip will come up for you that I think is well worth revising. And I've just now thought of one more, which is error intervals, which again is really easy to revise. And again, if you go on Hegarty, there are multiple clips for that, but just the first one is the one that you need to look at. But yeah, very highly recommended. So we'll get into some examples. And as I said earlier, if you want to have a go at this before I run through it, then you can pause the video now, and then I'm going to go through it and you can see how well you've done. So this is a fairly standard context one of these questions. We've got, what is it this time? Balls in a bag, but it's actually 2 different bags. So the first bag, we've got 3 red balls and 7 green. And in the second bag, you've got 5 red and 4 green. There are quite a few different types of probability tree question. And this context is probably the most common, but what you might see is that it's one bag of balls or marbles or sweets or whatever it might be, and one gets taken out of the bag and then a second gets picked. And you can get questions where the ball gets put back in the bag or where it doesn't. So there's quite a lot there, but hopefully this will remind you of some of the key points regardless. First of all, every pair of branches has to add up to make a whole. So where we've got that 3/10 for red, green has to be 7/10, but hopefully that's quite obvious anyway because there are 10 marbles and 7 of them are green. And similarly, we've got the 5/9 as the probability of red for the second bag, so it's going to be 4/9 for the probability of green. Those probabilities are the same on the next set of branches because what we're looking at here is what we call independent events. Because it's 2 different bags of balls and they don't interact with one another, whatever happens when you take a ball out of the first bag doesn't influence the probabilities for when you take a ball out of the second bag. We can now work out the probabilities of each of these sets of combined events. So the probability of picking out a red ball from the first bag and picking out a red ball from the second bag will be those probabilities, the 3/10 and the 5/9 multiplied together. And we just multiply the numerators and multiply the denominators. Do not simplify these fractions. Okay, when you do probability trees, don't simplify anything, at least not until the end if you're asked to, but you normally won't be. But if I continue that, the next one will be 3/10 times 4/9, which is 12 over 90. Then 7/10 times 5/9, which is 35 over 90. And finally, 7/10 times 4/9, which is 28 over 90. Now, I didn't actually need to work out all of those, but one benefit to having done that is that if I add all of these together, I can see that it makes 90 out of 90, which is how I can check that I've done this correctly. That's also why we haven't simplified. If you simplify some of the fractions, they'll have different denominators, so you won't be able to add them anymore. And then the part B in this case just asks you for the probability that Amina takes 2 red balls, which is just that 15 over 90. However, you could get a question that says, for example, find the probability that the balls are different colours. There'd be 2 ways that could happen, red, green, and green, red. You would then add those probabilities together. So work out all of them and then pick out the ones you need, add them up, and you've got your answer. The next skill I want to look at is scatter graphs. And, this is quite common. We haven't seen it yet. The first thing you should always do when you get a scatter graph question is draw a line of best fit. And it doesn't have to start from the corner of the graph. I want to be really clear on that. Your line of best fit essentially should be a straight line that represents the data as well as possible. So the one I've done here would definitely be mark worthy, but it could probably be a little bit better if I bring that down there. That's probably slightly more representative. I'm not trying to hit as many points as possible. I'm just trying to make sure that all of the points are as close to the line as I can get them with a single straight line. So I'm pretty happy with where that is now. Let's go back to the pen, sorry. And you should always do that at the start of a scatter graph question. If the points are really all over the place, then you can't draw a line of best fit, but that's very, very, very unlikely to come up. You could be asked now what the correlation is, and the answer to that for this question for 1 mark would just be that it is positive. That means that as the maths test mark goes up, the science test mark goes up. If the graph is going the other way, is if one thing goes up, the other goes down, so in this direction here, then we would say it is a negative correlation. You don't need to say anything more than that if that's what you get asked. However, what I'm more interested in looking at here is this sort of follow-up question. Jamie got a mark of 34 in the science test. Use the scatter graph to find an estimate for Jamie's maths test. The line of best fit here is really important. This question hasn't asked you to draw one, but if you don't, there is a very, very small range of answers that they'll accept. If you've drawn a line of best fit and you use it, it doesn't really matter what your answer is. You will get the marks, as long as it's done correctly from your line. If we go along the science axis, which is along the bottom, and find 34, which is there, and then draw a straight line, I'm going to do this freehand now, so it probably won't be very good. A straight line, it's not there, it's there, up to the line of best fit. And then we can draw a straight line from there back across to the other axis. That will tell you what the answer is. Now, I got 39. If your line of best fit was slightly different, you could end up getting something like 40 or 38, or it could be further away than that. You will still get full marks. That's the really important thing for you to remember there. The other things you can get asked are about anomalies. So if you've got a point that's really far away from your line of best fit, you might be asked about that. And the reason that's an anomaly is because it doesn't match the rest of the data. You could also be asked about estimating a value that sits outside of the current range of data that you've got. So for example, the question might say, this isn't a great context for it, but Jamie got a mark of 2 out of 60 on her science test. And it might ask you why that's not, why this graph isn't going to be a sensible way of estimating what her maths test mark would be. And you can simply say it's outside of the current range of data. You will get the marks for that. You're more likely to get that sort of thing with like race times and ages, where the data starts to make less sense when you go to the extremes. The last thing I'm going to look at with you is simultaneous equations. Again, if you want to have a go at this before I run through it, then please pause the video, have a go, and then you can check in with me. I'm going to label my equations 1 and 2. And what I want to do here is match up one of the variables, either the x's or the y's. And there's not necessarily an obvious way to go with this question. However, I'm going to match the y's. One reason might be because the coefficients are smaller, 2 and 3, rather than 3 and 5 for the x's. But also, when I match them, I'm going to then eliminate them. And the benefit of matching the y's here is that I'll get rid of that minus that's currently in front of the 3y. Now, to do that, I'm going to need to change both of these equations. 2 and 3 both go into 6. To turn the 2y into a 6y, I need to do the first equation times 3. And this is going to make a new third equation, which will be 9x plus 6y equals 69. And then for the second equation, if I want to change that into a 6y, I need to multiply it by 2. And this is going to create a fourth equation, which will be 10x minus 6y equals 26. The next thing to do is to use that match to eliminate, and we do that by either adding these equations together or taking one away from the other. And instinctively you might think, well, 6 take away 6 will cancel out, so I'm going to take away. But actually, where we've got 6 and minus 6, we want to add those. 6 plus minus 6 will make 0. We're going to do equation 3 plus equation 4. The rule that we often try and remember is that when the signs are the same, we subtract. And the signs are different here, so that's why we're adding. That's going to give you 19x equals, what's that going to make? 85? Just check that, sorry. No, 95. And then we can divide both sides by 19, which tells us that x is 5. Once you've worked out one value like that, we can then substitute it back into one of the original equations to work out the other value. I'm going to use equation 1. But I'm rewriting equation 1 knowing that x is 5. So instead of 3x, that's going to be 15 plus 2y equals 23. And then I'm going to solve that equation. I can take away the 15 from both sides. And then I can divide by 2. And there's my answers. X is 5, y is 4. And I can check that. If I substitute those answers back into equation 2, which I didn't use to substitute, I'll see that that works. 5 times 5 is 25. Take away 3 times 4, which is 12. 25, take away 12 is 13. And I can see that my answer here is correct. That might be more difficult to do if you get answers that aren't very nice. I've picked quite nice answers for this question, but they could be negative, they could be fractions or decimals, so just be prepared for that. I've gone very, very quickly through some of this. I'm aware that the list of topics that I've shared with you is quite long. I didn't want this video to become too long. I'd recommend going back to that list now and having a look at those topics. Past papers is still fantastic revision, but don't just do whole past papers at this stage. I think that's a really good idea when you're preparing for paper 1 and paper 2. But now that we know that certain topics aren't very likely at all to come up again, you don't want to waste your time on them. You can still get a past paper, but if, for example, Venn diagrams is in there, you did a question on that on Tuesday, don't do another question on Venn diagrams. Just skip it, move on to something else. Work on some things that don't seem familiar from paper 1 and paper 2, because they're the things that are more likely to come up tomorrow. Remember, you can also search for these topics on ExamQ. Maths Genie is also a good place to look at topics, but it's also a good place to look at exam questions. And Hegarty is going to be a good opportunity for some of the topics I mentioned earlier. In particular, things like the factorizing quadratics, error intervals, ratio 1 to n. I think they would all be really good things to look up. 2D and 3D shapes is also a pretty good shout if you're not sure about the names of some of those shapes. But I'm going to leave it there. Best of luck. Make sure you come in tomorrow with something that you want some help with. You'll have that opportunity to ask a maths teacher to explain something to you. If you come equipped with something that you've struggled on, then we can get that help to you really quickly. But yeah, that's all from me. Have a good evening. See you tomorrow.